Okay, so last week we talked about piling, and we had three main forms of piling systems. That was the key discussion point that we talked about. So we've gone through the three forms of pilings. Can people list them to us? Can you guys just write them down or just list them to us? What are the three types of or forms of piling systems?
Soldier piles, secant piles, and there is one more.
Yeah, contagious, that's right. Yeah, the contagious piles. Yeah, that's right. So three forms of piling types. And as you can recognize, the three types, they basically based on the pile element. So we're always gonna need to build or construct that element. And then with the soldiering type or the contagious type, there's gonna be some concrete filling in between them, whether it's gonna be as large as 1.8 or more, or it can be as small as 50 mil to 100 mil. Then if we really want a very tight system, we're gonna go to the secant where the pile's gonna be interlocking with each other. So that was the key kind of topic we talked about last week. Then we've seen the projects that I talked to you about. You have to carefully know the different components that will form up a retention system. So quickly going through them, just the main ones. We have the pile, as I mentioned. We got the pile cap. We got the shotcrete wall. We got several elements within the shotcrete wall, which is to do with the drain strip, starter bars. In cases where we can't deepen the pile into the ground, we should use anchors, and we talked about the situation where we can or we cannot. So that was really what you need to know. We've worked with the engineering drawings, the school project during the workshop, and we started just talking about the first two questions for assessment 2 that you should start doing or working on. So that's where we are, and this week we're gonna talk more about the construction methodologies. And beside that, so today we will not only talk about those piles we mentioned last week, we will also talk about different types of piles. For example, driven piles. So today we're talking about construction. They can be driven or they can be bored. We will talk about those things today. All right, and in relation to your submissions for the first assessment, we're going through marking them all, and hopefully before your break. Next week is a break, so no study, no study with us yet. You definitely can study and work on your other activities during the break, but there won't be lectures or workshop. That's next week. Yeah, you good to very good. So work students have been doing with their first assessment. Yeah, maybe next time I can talk to you about main issues found. So I think, yeah, just again, few groups or students, it's kind of rushing or haven't really discussed or came to the workshops and know really what we are talking about. So few groups really, especially when we're talking about the concentrations. They talked about very generic points. They did not talk about the framing elements we discussed during the workshop. So when I was talking in question 1 and 2 about what elements the construction engineer will be using in order to achieve efficient design or construction, The answer was just very generic, nothing to do with the elements. So that was that was, I think, one of the issues. You still took some credits for what you've written, but they were not the key answers. Yeah, and we have carefully talked about them during the workshop, so they're supposed to be there. Yeah, and so I think the response is quite good. Some of you done very good. Yeah, so hopefully you will get them back by the end of this week at some stage. And yes, I will also provide a solution sample, which is from the students as well. So some of your students have, some of the students within the subject have given a very outstanding typical responses, and you will have the chance to see it in case some questions will come back to you in the final exam. Okay, so let's talk about this week. Any question, any general question before we start? This week, the workshop's going to be on campus for Bendigo, online for Bandura. Any other questions or things you want me to clarify before we start going through the slides? All right, so what we're going to be talking about today is this. Yeah, so piling system. Last week we looked to the types, we looked to the components of a piling system for the 3 types, and we looked at some case study, a case study with also the workshop. We looked at a different case study by reviewing and observing the drawings. This week we will talk about construction methods, and construction-wise, the piles can be divided into 2 types: driven piles, which is basically precast, so the pile is going to be built somewhere, as in concrete, or they can be steel, and then you're going to bring them on site and just hammer them into the ground like nails into the ground. We will talk about them within a few slides. Then board piles, which is what we talked about last week. But today we will talk about the key considerations when building such components. Then one of the main type of, as I mentioned last week, of boarding piles, it is continuous fly auger. So continuous fly auger, CFA, it is again a construction process to build and construct piles into the ground, and we will be talking about it today. Now, one of the challenges found when constructing piles is you may have very loose material in the ground, or maybe water table that will keep filling the hole you dig. Even if you want to use the CFA method, it won't work because the water will be coming into your hole while your auger is still in the ground. So there is a solution to do that by using the bentonite. This is just a product that people will be pouring and placing into the ground, which will allow for temporary shoring. It will allow for temporary, it will allow as a temporary hold to stop the water from seeping into the hole. And then the very last type of retention, we'll talk about steel sheet piles, which some of the students last week talked about. So it's just a steel sheets, but again, it's you're gonna see where it's used at limited situations where you have very sandy soil, and you just want to stop that sand from collapsing. And we'll talk about this as well, which situations such system can be built. All right. There is some recommended references that can talk about such methods, and also they are available in the reading materials. There are reading materials as well available. So starting with the first construction method for building piles, we've got the precast driven piles. Now, one thing I want to mention to you with these precast driven piles, they won't be forming a retention system. Mostly we use this in constructing roads or constructing the piles below towers. You see most of the buildings in the city, before they start building the footing, they're going to be nailing down piles. These piles will be basically there to take axial loads. The piles that we talked about last week, they are basically for a retention system for retaining walls. But today, especially driven precast piles, they can be to improve the soil conditions under a building or under a road. For example, if you've been here, I'm not sure for your case, maybe you came to your course 1 year ago or so. About 5 years ago, they have done a redevelopment for the major redevelopments through the Western Ring Road. And there was a long segments within the Western Ring Road where they had very soft soil. And so basically, if this is your soil, that's the soil level, and you've got sections or areas where the soil is basically 2 meters maybe fill. Definitely you can't construct a road on top of such soil material. And one of the options, or most likely the option for such situations, is to build a concrete floor, reinforced concrete floor. Then on top of it, you can put the asphalt. Maybe you can't feel it really if you go over some of the segments within the Western Ring Road. It's not over the bridge. The bridge, we know the bridge is suspended, but there is still, you are driving on the ground and you feel the slab is suspended. It's from the expansion joints. And basically because the ground or the road is actually built on, let me just change the color here. It's built on this red concrete slab. It's basically a concrete slab, right? It's a concrete slab, and the slab, it's like suspended concrete slab. And the slab is really sitting on piles. So just going back to this color, let me just take this away. It's piles. They are piles. You got them every maybe 1.5 meters, every 2 meters. They go as deep as 30 meters because you will have a lot of weak soil. Maybe goes for 5, 6, 7, 10, depends on the soil report. So what I'm trying to say, driven piles, they are used to vertically support the superstructure, whether it's a road or also under the buildings, under the towers. Usually we've got those driven piles. They typically precasted, and then they will start knocking them down. So yeah, these kind of cases, the pictures I'm going to show you next, they will show you the hammering process or the driving process for precast piles for road construction, right? So don't get kind of mixed up. You think always the piles are there to do a retaining wall. No, they're also there to vertically carry buildings. If I got the chance, maybe during this week's workshop, I'll show you structural drawings for high-rise buildings. Basically, you know, they got a pile cap on top. So I'm not sure if you've been seeing, there's like this is pile cap, and there's a column, very big column, which goes for those 40-story buildings. So maybe 1 meter by 400 thick, very long column. Now that column will be sitting on what? On a pile cap, and then below the pile cap, we got maybe 6 driven piles. So again, we use those driven piles to not as a retention system. I just want you to understand what we're talking about. Driven piles, they are used to take vertical loads, and I will show you some of those examples maybe during the workshop. So in an elevation, this is your pile cap. The pile cap is sitting on the driven piles, which can go 20-30 meters into the ground. and on top of the pile cap, you will have what? That big guy column which goes up, because basically the soil is very weak in that area, and again we're carrying a long tower there, so the loads are really strong or very high. All right, so that was just a general understanding about the piles that we are talking about. They are not really meant only to carry a flexure like what we were covering last week. So driven piles, they are definitely can be cost effective, especially if you want to hammer into silty sands like very soft soil, gravel, or just filling material, which I said to you, there is a lot of areas within the CBD, close to the docklands, or even in different suburbs, you got areas which can go up to 3 meters of fill. And yeah, that's where you can think about piles. Now there is an issues with this. We'll talk about it. Sometimes you cannot just hammer piles in the middle of the suburbs because there is a sound problem and vibration problem. So we will come to that. The shape of those piles, they are typically square, and they can have different sizes. And obviously each size, or whenever the size go up, the self-working load. This is the self-working load, and this is the ultimate load. So typically, just in engineering drawings, which I may share with you during the workshop, from our engineering drawings, they're going to show you the pile cap, and they're going to show, as I said to you, they're going to show you a pile cap like this, like a footing plan, a pile cap, and they're going to show you piles, circles, and then next to each circle they put what? They put maybe P1, 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 then P1. On the drawings, they're going to say to you, P1 should resist this much of kilonewtons. So the contractor who will be doing the piling, they are engineers as well. They have their own engineers, which should, with their equipments and hammering facilities, they will end up doing tests for each pile to make sure it's actually stopped and cannot go anymore into the ground, and it's actually can resist these figures. So that's how it's working. During the construction process, they're going to verify the load the engineers wanted a building to be supported on. So yes, the engineer is going to calculate all the loads to the footing, but on their drawings, they're going to say the piles should take this many of kilonewtons as a surface working load. Now that's what typically construction engineers work with. This is the ultimate, in case they also want to specify the ultimate. And the engineer sometimes can calculate the ultimate. Just got more safety factors. The service working load, it is to do with the working load when they want to check the settlement of the soil, because they will say the settlement should be very minimum under this load, because we are worried about deflection, like the whole building gonna be sinking into the ground. And usually these we're talking here about very few millimeters, especially during construction. But ultimate, it is to do with the strength. So usually the self-weight is the safe working load is smaller than the ultimate. And when the construction engineers or the engineers who are looking after the piling contractor, they will make sure these figures are met. So wherever you're hammering, you're going to be checking. So where you stop typically commonly at effective refusal. That's what we mean. Effective refusal is you keep blowing, keep hammering a pile, and it's not moving anymore. And that's where you have to stop. And there is a standard which tells us when to stop. Like they will say, if you hammered the pile this many of times and it did not move only these few millimeters, then you can stop. And then you can do a test, and that's it. And you have to make sure within that test you are reaching these figures. That's basically the task for constructing a pile. It's just like a nail. You hammer it into the ground, and then you stop when you receive effective refusal. Then you test it to achieve such values. Job done. You go to the next pile. The strength of those piles, obviously, it's a bit high, 65 MPa, because it's under that impact. So it's have to be really rigid enough. It's like a nail, you don't want it to break before getting into the timber or concrete. So same thing with the piles, they are really strong. They got high compressive strength. To start, so they build it in the factory. As we said, they're going to build it in the factory, and it needs to reach about 20 MPa to start carrying it. All right, so we start carrying it at 20 MPa, because again, you don't want to carry a pile while it's not strong yet. You want it to be a bit hard. Usually they wait up to 20 MPa to start transporting it and lifting it from the factory to the truck, from truck to on site. Sometimes, just to let you know, they may decide on building those piles on site. So that's another option if we're talking about constructing roads far away from the city, where it will be decided the factory, or they're going to have a temporary factory next to the site to really develop those precast piles. And before you start driving or hammering the pile, it needs typically to reach 50 MPa. Now, how the pile really support loads, how the pile really support itself. This is a pile. I'm just drawing here for you a pile driven into the ground, and that's the ground. Now you need to understand, with the piles, you've got two components to resist the load. So this is the load coming from the top, P, right? From maybe a column, from a wall, etc. So the first component is the bearing at the bottom. You've got bearing stresses. So the arrow should be looking upwards. You've got bearing stresses to resist the load, but this is typically not enough. I know when the pile is going to be sitting on a rock got very strong bearing capacity, and usually even if you have 400 diameter pile, if you multiply 400 by say 300 MPa, this will give you a decent number of kilonewtons. So because you're just going to multiply the area of the circle, of the 400 diameter circle, multiply it by 500 or 400 MPa. That's usually the bearing capacity for rock. Then it will give you a good number, very good number of kilonewtons, but typically it's not enough. So what we use else, we use the skin friction. The skin friction that I'm showing you will be another important component for us to use and calculate the total P. So here we've got PA and also P2, PB, let's call it, and then how it really works. The engineers will be calculating the addition of both of those components together with a safety factor. So we reduce it by safety factor, then make sure it's more than or equal to whatever force is going to be applied. So the key message from here for you was just to understand with piles, they not only resisting an end bearing like a typical pad footing, they also resist skin friction as well. Not end bearing capacity only. Yeah, like a pad footing, you all know, or you studied that. We don't use the skin friction because it's only about 0.5 meter deep, but the bearing usually in pad is used. Okay, so equipment used in installation, there are really different equipments outside, which just depends on how high is your pile, how the capacity you want to reach. Yeah, the safe working method. I've got some examples where piles can be used in a small residential area. So a small machine can be used to do that job. But basically, these machines got the ability to do the lifting for the piles, and then they're going to be going to. So you see, this is again a road. It's for constructing roads. They basically, as I said, this is very soft soil for a couple of meters. The solution here is to nail down, to reinforce the ground, so they keep hammering piles in. over specific distances, then they're just going to build a suspended concrete slab. Then on top of the slab, they're going to put the asphalt. Right. Now these piles usually they are specified by the tons they can actually hammer with in terms of the weight of the hammering components. So usually it's between 5 to 8 tons, 5,000 to 8,000 kilograms. So they keep lifting that mass. It's within this machine. They lifting that mass and dropping it on the pile. And then the pile will basically get driven into the ground. The second point here is talking about sound attenuation housing. So sometimes if you have issues with sounds, these equipments they come up with kind of a housing container, which I may be able to show you next. A housing container which will be close to the ground. So something like this that they're going to be placing around the digging point, and it's really helped to reduce down the sound and impact when the council will ask for such requirements. I remember when they were building that Western Ring Road, so yeah, it was too sound. You can always, when you drive next to it, you can see the impact, so it was not an issue maybe, but usually if the sound was not acceptable within above limits, then the builder may need to allow for the other system where it's ended. I think it's something like this. So I think I've seen it in other cases. They have different arrangements where it will actually just hold in the sound. So just stops it from distributing from the impact point. It's like a container which goes around the hammering system, and just to take down the voice. It won't take it completely. There's still going to be a voice, but kind of just reduces the level of sound that may be sourced from the impact. So bearing capacity achieved if we receive effective refusal. That's what I was talking about. So usually you will stop nailing this down. And well, one thing to mention here is sometimes one pile is not enough. Sometimes you can actually put 2 piles on top of each other because you did not reach refusal. So in case if this was 9-meter pile, hammering it into the ground and you're still getting that soft sandy soil, and you did not receive your self-working load, the 1,000 kilonewton, you can go and put another one on top and hammer it again. But yeah, basically you will stop as per this table. I'll talk to you about this table, which gives a guidance for the contractors about when to stop the piling, the driving process. There should be dynamic testing between 3 to 50% of the piles. Now, the tests really, as per regulations, if you got 200 piles on a construction road, you need to do, there's going to be agreement. You won't be doing them all because you've already stopped at whatever blows. So each pile was actually stopped within a standardized process. But in order to make, to kind of make sure things have been tested, you will be testing 15%, say, of whatever piles you installed. There is a note here about vibration, which is, yeah, as I said, sometimes the whole idea of using driven piles can be rejected. That's where you may be going to the board piers or board piles, the one we talked about last week, and we're going to talk about it further this week. Because of the sound issues and the vibration, it may damage a tunnel near the project, or a water pipe, main water pipe near the project, or houses. Maybe there's a lot of houses which is very close to the road, and they don't want to damage the houses. Then someone gonna need to fix them all, especially if we're talking about some heritage properties. So this table gives guidelines about when to stop the driving process for the piles into the ground, or where you can reach effective refusal. There are some examples. For example, if we're talking about the 350 square pile, so 350 by 350 pile, typically for short piles, which is about 12 meters, you should have 20 millimeters for 10 blows. So you should, every 10 blows, every 10 impacts, you should be displaced, or the pile should go into the ground by 20 millimeter. That's minimum. And the dropping height for the hammer is 600 millimeters. And if you have a long pile, 30 meters, you should typically get 30 millimeters for 10 blows, or 600. If you're not really getting these numbers, if you start getting maybe only 10 millimeters or less, that means you can't stop really, because you're getting those kilonewtons we after. And remember, you will be doing a test later on at the end of the project for about 15 or between 3 to 15. It depends again on the importance of the project, and what the regulation will say. If it's a building, usually we go sometimes maybe even more than. For building, we don't have that large number of piles. You may have, as I said, 6 under each column. And usually buildings are, say, 30 or 40 by 40 meter. We're talking about towers. They're usually not. They're not that huge in terms of a footprint area. So sometimes they may agree about testing all the piles if they really want, because they're not a lot. They may have only 40 pile in the project. So for a peace of mind, they may just agree about testing all of them. Dynamic testing, as I said to you, there for those 15% or whatever agreed, they may come back and start to apply some vibrations into the ground. And the vibration, there is techniques. You don't need to go through them. We do have different subjects where we tell the students how this is done with the equations and all the processes. Basically, you will have an equipment like this, which will apply dynamic load onto your pile. Then the engineer will be measuring what's happening with the pile. So there are some sensors that will be connected to the pile which you've already built. So this is the pile, it's already into the ground. And what you're going to do, you're going to be connecting that pile to this dynamic, what we call it a vibration generator. So this is a vibration generator which will be attached to the pile. Then this system will be just providing kind of, say, harmonic motion, something like this, right? It's a sine curve. That generator will be applying a motion like that. Then with some equations, the engineers can work out the stiffness. You know, the K stiffness, if you remember, stiffness property. For that just for your understanding what's happening. So we can calculate the stiffness from some dynamic equations. We all know stiffness comes from or represents force over displacement. Okay, so force, we are able to work it out. The displacement is what we want. Okay, so there is a mathematical process by using dynamic principles, which usually the engineers who are going to be working for those testing companies, they're going to have their own firm, and basically they're going to have their own engineers to work out the stiffness from the dynamic response. Then when we calculate the stiffness, we are able to calculate the displacement, and we just need to check where we are with this table. We're just going to check where we are with this table. If we have very limited displacement, we are okay. And then in addition to that, the dynamic testing will be able to give you, to confirm these figures we're talking about here. Or ultimate, depends on the cases they are looking at, whether service load or ultimate load. So definitely, if the force there have already achieved, because remember when they're testing the actual resistance. So no factor of safety. So what I'm saying, that most likely they have to get a number above the ultimate, then work out, take away the factor of safeties and find whether it works here, works for the service loads. All right. So for this subject construction, what you just need to understand is basically there is testing for the piles. That's what you need to understand. And basically you need to understand the reasons behind why we use the pilings, what the issues we can have from the piling systems, for example, the sound and vibrations, and how the piles resist load, which we said by the bearing at the bottom, and also the side friction as well, right? You won't be asked about, about these equations. You just need to know the construction intent and what's really happening there. So that was basically about the driven piles. So as I said to you, in terms of constructing those piles, they can be driven, hammered into the ground, or they can be bored, like what we're going to talk about next. Is there any questions some people want to ask about for the driven piles?
So like you said, these are precast piles. So
Yes.
you also said that you stop hammering after a certain depth or like at an effective refusal. Basically, you stop hammering. So my question basically is, if like you stop midway, what happens to the pile that that remains on the like above from the ground level? Maybe
Yes,
like,
excellent. You just saw cut it and use it somewhere else. Saw cut.
so we cut it from the top?
Yeah, saw cut.
Saw cut. All right.
Saw cut. You just if you hammer, if you start now, that means you had a very poor soil report, which did not tell you the real nature of the soil, which should not be the case. But in case you did have a floating rock, so if I have a space to draw, yeah, so this is your natural ground level. And definitely these things going to be studied over months, to find out the topography of the soil. So basically you will have very clear strata for sand or silty clay or fill, or but I do understand your point if we had a rock, and I think it can happen if you had a rock, and if you your pile have been clashing with the rock. That's where the engineers will be consulted again. Especially with such major infrastructure projects we're talking about. I can tell you in residential, we ideally residential, medium-sized buildings, we just tell them stop. Whether board piers or like if you're going to use the auger as well, you just can't stop here, no problem. But when you're going to nail piles into the ground and you face it, I know your question was about you have half of it up, so you just saw cut it, and then you can use this. Maybe if you had the strata maybe somewhere, the rock somewhere here, you can use a pile. Maybe your pile is already that much, so you can use this piece again here. Yeah, that's what they use. You can actually use multiple pieces on top of each other. You just kind of nailing into the ground. You want to make sure this will have adequate bearing. It's gonna get refusal, adequate bearing on the side, and adequate friction on the side, I should say, and adequate bearing. Let me put it with a different color at the bottom. Then when you get that refusal, you will saw cut, or you keep hammering down if you did not. So the question for you is saw cut. One thing I want to bring to your attention, there are two types of piles, driven piles. One of them is with this pointed or sharp end, and also there are types with a flat end like that. They use the flat end in case they are a second section to hammer on top of an existing one, right? There are some locking in detailing. Ideally, I've seen on site they can just use, so before they can use some dowels when they crane these things on top They can use some dowels to connect them together. They can just drill an epoxy on site, just drill and put some epoxy, and then they can have another kind of drilling here too, just to have some mechanical connection between them. Right?
Todd, you also talked about the columns. So about I was a bit confused about that. I didn't interrupt you at that time. You talked about that there will be like a main pile that is basically a board pile, and then you have like 6 of these driven piles around the corner. I didn't get that point clearly.
Are we talking about driven piles or board piers? Just to remember, what are we talking about here?
So it was basically about a column. It involved a column and 6 of the driven piers.
Is that something we talked about last week or this week?
Today, sir. Today.
Today. Okay. You know, so you understand the exact. Okay, you understand that this project. Do you know what we are building here? Kind of.
It looked like earlier you told it was a road, but
Correct.
I can't like make out of it from.
Yeah. All right. No, it is a road. Definitely, you can see from because I'm not sure if it's very difficult with. I know it's very like it will be very good to take students to these projects, but we typically face issues with the timing. They don't do exactly what we want to show you on the time we take the course. That's one problem, and safety issues. There is a lot of safety issues which stops us from. But it is a road, and these kind of arrangements, you see them in a lot of new suburbs where I've seen them in the way to Bendigo as well. About, again, 3 years ago, just before COVID, they expanded the road. And let me give you some more explanation here. As I said, if this is let's talk about the road first. Right, so this is the asphalt, say, road, right? So usually, as per what we talked about last, on the like industrial slab. Remember we said when we put our industrial slab, they have to be sitting on a proper subgraded ground, like prepared, compacted, and the soil report will tell us it is a very stiff clay. So here we may have with this purple color, a stiff clay, which won't really be, it will be definitely doing all the job. Then you got kind of basalt, and under basalt you got rock. This is kind of a very safe, strong ground structure where you've got stiff clay. You may have a little bit of sand at the top, but it's going to be cleaned off. Then you have a stiff clay. Then you got basalt with some floating rocks. Then you got rock. This is kind of really the best levels or layers of soil below a road or even a building. Now, in many cases, while they're building a highway, this is a cross section, by the way. Yeah, this is a cross section, so the cars will come into you and going out. Yeah, you with me? So it's coming into the page. You with me there?
Yep.
So what they do sometimes, or many times, especially in the region of Melbourne, or even you've got maybe 2 kilometers, right? Which it's very soft ground. It's maybe there is some ground movement or whatever. You don't know what's really behind it. It's more to do with geotechnical engineers. They found there is a section which is all fill. So basically it's all fill. It goes for maybe 5-10 meters, whatever. And the road will just keep sagging, which won't be acceptable. So you're going to be sending a very large, there's a major companies who do soil testing, like Coffee, one of the major, one of like the names that are available, which do very decent soil reporting. Coffee, that's what they call themselves. I've seen one of their reports, they go as big as 500 pages. and they will give you exact details about what's going on in the soil, and also they're going to give you recommendations what to do. So they have engineers who also know about. They give you a recommendation. They say definitely you have to use driven piles. You can't use you can't use just you can't enhance and prepare the soil. They will give you all those advices. So what we do in this case, and just say after 6 meters here, say you've got a proper soil, maybe that clay I was talking about. What we do here, then we have to nail in driven piles, right? With the techniques I was talking to you about. So they're going to be every maybe 2 meters. And then on top of that, we're going to building basically a suspended, I'll put it in purple, a suspended concrete slab. It's just going to be a concrete slab reinforced with top and bottom reinforcement. So effectively, your system is just suspended slabs sitting on columns, right? And each needs to take maybe, as we said, thousands, a lot, thousand. Then the engineers will be designing a concrete slab to suspend trucks, to suspend all those loading. It's just going to be suspended. It's like a flat slab. Remember in week 1, we talked about different type of slabs. We talked about banded beam slabs, flat plate. Basically, this is a flat plate because there is no beams and band beams. So it can be as thick as 300 or 400 thick piece of concrete slab sitting on piles. And that's really what's happening in this picture. They just at this stage, they are just nailing down those both piers. Now, I was talking about columns. It will be great if I have access to the drawings, but I think it's going to take some minutes because I do have, maybe I'll share with the students Wednesday, a footing plan. So let's say your school project or let's say this is a footing plan for a building, right? And definitely you've got columns. This is a plan view, yeah? You with me? This is a plan view.
Yes, sir.
Yeah, you've got columns. You do need columns for you. I'll show you real drawings later on when I get the time to search for. Now, imagine we have here maybe 40-story building, like a tower. Okay, now you would usually, if you have a short building, like 5-story building, you're like per what I shared with you with the school. You're simply going to have your column sitting on a pad footing, and that's it. The bearing capacity under the pad footing was good enough to carry the load above. Done. But when we're talking about high-rise building towers, usually the bearing capacity under the pad footings are not enough to carry them. So what we do, we put piles. We put maybe, it depends, sometimes 3. I'll show you the project again. Sometimes we have maybe this guy is carrying a lot of maybe 5,000 kilonewtons. So it will have a pile cap. The pile cap will be sitting on driven piles, but we don't know how we did them. Whether driven means they are nailed, or board, they means we use the OGA continuous fly. So that's what I was talking to you about. Then my piles will be here. You've got 3 this side and 3 the other side. So basically that's what I was showing. And same thing for this. Maybe if we have a small column which takes less load, we have the pile cap looks like that, and we may end up having only 4. I'll show you. Sometimes we have 3. And the engineering drawings will tell you each pile will take 1,000 kilonewton or 1,500. So when the contractor, the engineers who are going to come and do the piling, usually the piling got their own company. They got their own. And yeah, even these lecture notes, some of them were prepared by an engineer from a piling company. Okay, did it make sense what I'm talking about? So it's a different project.
Yes, that's what I was a bit confused about, but it's now clear. Thank you.
No problem. Okay, so looks like we're done with with the driven piles. And it's a type of construction well used in the construction industry, and it's got its own challenges and own features to talk about. That's basically what you need to know from this subject. Board piles. Board piles means it's what we talked about last week. You're going to be excavating a hole, then throwing your concrete. But as we said, depends on the soil. If the soil is holding itself, then you can dig your hole, put a cage, pour the concrete. If the soil not holding itself, then we have to use the CFA method, continuous flight auger, right? So we had this case here, which is talking about the situations where the soil will not collapse. So that's again the case that we are talking about, where the soil property is actually kind of stiff clay or a clay, and we don't need to go very deep. So maybe we can be up to 20. Sometimes we may need to go more, but yeah, the depths for these ones can be in the excess of 30 meters, and they can come up with different diameters here. So we can be 400 diameter, 900 diameter. For civil works, I think one of the students last week talked to me about very wide opening, and I can see here it's saying to us those excavations can be up to 3 meters, especially for civil works, because you want to make a pit. And yeah, I've been seeing these cases. Usually when they dig such diameter, it's not one machine that they're going to bring to dig this much. I've seen a case where you've got, say, this is the 3 meter diameter. They basically going to make different holes. They're going to use maybe the 900 and keep digging until they achieve it. So they don't really have a cylinder which goes 3 meters. They will just do it at different stages until they achieve the 3 meters diameter. Yeah, sometimes, as we're going to talk about next, so this kind of type of topic, it's linked with what we're talking about later on. So because they're saying if it will it will start collapsing to itself, or we hit a water table, so we got water leaking from the underground, then we can use the technique of placing bentonite. We will talk about bentonite. It's just another kind of product with high viscosity that will stop that water from getting into your hole that you're digging, right? But we will talk about this later. So I can tell you this option again, it's used in the residential. In the residential, we don't need to go 30 meters. Usually the best we go to is 4 meters. We're talking about 2 or 3 story developments. All what you see in the residential, you won't be going more than 4 to 5. Depends. If you have, usually we use board piers with tree issues. If you got trees around the property and the trees seems to be very active, like they keep absorbing the moisture from the ground, because that's a problem with the trees. If you have trees around your property, they will keep taking the moisture and making the soil or the ground not stable, because whenever it has moisture, it's going to dry away the moisture, depend on the season, and then that will keep, will cause movement into the ground. And because residential properties are not as heavy as a tower, then that will cause that movement I was talking about can actually move the house itself or the wall, and then cause those cracks into the building. So as a solution, the engineers will specify board piers. And usually, as I was saying, for residential, we're talking there about 4 to 5 meters deep board piers, not very much. And this would be the option to go with. Nobody will use the CFA method in such developments, right? Let's go. Right, so here we're talking about sometimes if you want to go through rocks, you will start using this auger techniques because that drilling bucket may not be helping. So if you got those floating rocks, you may start using some auger technique. So here I'm not talking about pouring the concrete yet. We'll talk about this when we get to the CFA pouring technique. And sometimes you will require temporary shoring components like those cylinders. I think I showed them to you last week, or there we have some of those cylinders. Yeah, these cylinders temporary. If you want to dig to those, say you have 10 deep board piers, 10 meters deep board piers, and then we typically may have some disturbed soil at the top. Maybe the first meter or meter and a half, it's very unstable. Then while you dig for the 1 meter, you can hammer down or replace those kind of shoring components just to help you for temporarily propping that soil. Okay? And then you may get the clay from below that level. So if you have a stiff clay, the clay can hold on to itself if it was not rainy season. Now, all those decisions, I know it will be experience. So you will see with people with 3 years experience within this area, they know this suburb can work like this with confidence. They know that I can't build those without no issues because they've been doing it for 3 years and they know this suburb or that suburb got this type of soil. And the soil engineers as well in the reports, experienced soil engineers will know what's going on in that development, in this development. Because, you know, we're not talking about a purely new area. If you're talking about a new state or a new area, then a proper soil report will be required. All right. Yeah, that's just a picture showing us here. I think we start here talking about those pictures. It's what we talked about last week. We're talking about so these kind of components, yes, they can be built as board piles where you may have a clay and you don't need to use the CFA method where you have to pour the concrete before taking off your equipment. And get it. You all know these components, and I think that was just to connect what we taught you last week with what we're doing this week. One of the things you need to recognize as a difference from driven piles, as I said, driven piles usually to reinforce the soil, to carry the road or to carry a tower. But these guys usually, they will have the opportunity to build a shotcrete wall beside them, or sorry, between the piles. You will have the opportunity to place the shotcrete wall. But with the other options I was talking about, it was not for a retaining wall. It was basically for taking axial loads, future axial load. Right, so on this slide, I'm talking to you about we're still talking about board piers, but in this case, you will have many situations where you don't really experience stiff clay, which is holding to itself, and the hole, and the hole really you're digging will start collapsing to itself. So what I briefed you last week about, simply in this case, you're going to get your auger, your machine or your equipment will be associated with a pump in the middle. And as your auger going to go to the depth you are interested in, you will then start pumping the concrete while you're lifting the auger up. When you reached the depth, you will start you will start pouring the concrete. So after reaching the design toe level, so that's the very bottom of the pile, the concrete is pumped through the whole steam of the auger while the auger is extracted. So basically that's the key difference, is you pour the concrete while lifting up the auger. All right? So there are kind of key considerations when you do this. They need to make sure just to make sure that the concrete pour or the concrete got no gaps within the pour. So ideally the toe, the tip of the pump need to be always embedded into the concrete. Yeah, as you lift the toe up, you have to be, and you're gonna see, I'm gonna show you some snapshots or pictures for the equipment which does that. For the monitors, it will tell the contractor that and that's again, as a construction engineer, you will be asking for such documents. Right now, I don't know, nobody knows. We all been working in different areas within constructions or design, and they're all perfectly gonna build up excellent skills. So what I'm trying to say, I don't know whether you're gonna be supervising the contractors who do this work, or you're gonna be the builder who's gonna hire those companies to subcontract such project. But don't expect that if you are the main project manager, you're not worried about all these kind of details. You have to at least ask for certificates, proof that the job was done properly. Talking about this process, one of the key things is you need to ask for reports showing that reports that will ensure the pile is actually built cohesively. What does that mean? There are some documents. Let me just show it to you now while I'm talking about it. For example, this is what you need to see. I will talk about this later on. This is simply going to give you all the information the construction engineer need to verify to make sure my 100 piles or my 80 or 20 or whatever number of piles, they are correct, right? They will tell you that you had adequate pressure, continuously adequate pressure on the pumping unit that will confirm there was no gap in the pile, right? This will also confirm to you, we're going to come to this, this will confirm to you the depth of the pile, the diameter of the pile. Here is the diameter of the pile. That's the pressure. You need to make sure there is always a pressure positive to make sure that the end of the pile where the concrete is pumped was always below the level of the concrete. Because if they pull the auger very quick, then you're gonna actually start spraying, which is not right process. If you spray concrete, it's gonna be weaker than just pouring it from below the level. So if I just give you a sketch here, if this is the pile, that's the depth, that's the design depth at the bottom. The bottom is the design depth. So I will make the concrete with the blue. So you're pouring the concrete up to here, for example. You have to make sure your auger is always, this is the auger, it's always below. Sorry, it's not perfect. So that's the auger. You need to make sure it's always below the level of the concrete as you go up. Yeah, you can't just get your auger above. You can't get it above like this. I'll try. Sorry, the blue line is going with it. Should not go with it. Yeah, so it cannot be like this, where your auger is actually above the concrete level, because you will start spraying and the concrete compaction will be very poor. So basically you need to ensure compaction. Yes, as a project manager, you need to check all those details. Anything goes wrong, you need to say it was done in the right way, and there is another problem which has nothing to do with you. All right, so this is kind of the documentation you need to know about. Let's go back to where I stopped. Okay. Okay, and people asked me this very good question last week. The last point we have here, it was how or when we're going to place the reinforcement. We just simply going to get it pushed. If I have the chance today, I'll show you a quick video to show you how they place the reinforcement. So they pour the concrete up to the top, and then they take the machine away. Then they're going to just push down the cage. We will see that. Some pictures. So see, maybe the machine is just digging and pouring for the concrete. at that corner. You have here the different augers you may connect as long as you want. Yeah, the soil report will guide you, say maybe 9 meters, 12 meters deep bored piers with the CFA method. If they needed more, they can attach more and get going more into the ground. Once they reach the design level, they start lifting up. They start pouring the concrete and slowly lifting up the auger, just to make sure they have to make sure the concrete level is above the pouring end for the concrete. And then after that they're going to be placing the cages, the steel cages, into submerging it into the hole. And as I said to you before, this is just a temporary shoring if required. I usually placed at the first layers, or the first at the top of the hole. Yeah, some good information about the CFA: quiet, fast, economical form of piling. So yes, if you have a collapsing situation, which you can find many of them happening around, then it's just going to cost you a lot of time to think about boring your concrete with the classical method, where you just excavate and then put your cage, then pour the concrete. Yes, very suitable for soft ground where deep casting or user drink fluid might otherwise be needed. So we're talking here about the bentonite. I will show you next. So still, we may face another problem. Even if you're using CFA method, you may hit a water table, and then the water will keep leaking, and the problem there, the water will get mixed with the concrete. The water may get mixed with the concrete, and then again you won't have a pile. You won't have a concrete pile anymore. You're gonna have another material, another wrong material. Yeah. So usually the soil, the arrangements that you need to know about is usually there is the soil material you excavate. It will come to the surface, and typically, like usually, you need to worry about where this material gonna go. So it's either the council will give an advice where to dispose the material, or if you can use it somewhere. All right. Any question? Okay, let me give you how many minutes break you want, guys? Let's meet again at 9:20. Let's maybe have a break because we're already past 9. Let's have a break for about 6 minutes, and we continue talking about the CFA. Okay, so let's keep going. CFA. So we have a quick case study that can bring the numbers together for you. This was an apartment building, Port Melbourne. Definitely Port Melbourne would be a situation where buildings or apartments or unit developments going to be sitting on piles. It is about 300 meters from the Phillip Bay beach. Obviously, sandy soil will not hold a vertical face. So definitely, you cannot. If you have a sandy soil, you will need to rebate it with 45 degrees like this. And as we said, why we don't do this cut for our basement, if we need to build a retention system, we may have a neighboring properties and we can't really do that. So if you have a sand, you cannot cut it, as I was saying, something like this, 45 degrees for the basement, because maybe here you've got a boundary line. So you're not able to use this space. For this project, the pile seems to be anyway required to support vertical loads. So it seems that it's not for retention system. It's for just vertical loads. That's what we have here. All right, so let's see what else we can know. 450, that's the piles that were used. 450, 500, 600, which, as we said, there are different sizes, depends on the design engineer. Usually obviously the concrete workability will be really high, and you can see the slump test here is very high. We think we talked about slump test in week 1, which gives you the workability. They are very, very high. Obviously for within the tight circumstances. So usually if you've got a pile, you need to ensure there is some sort of a cover. That's your pile, and we're gonna have a cage placed in the pile. This is the reinforcement. I'm trying to draw it as best as I can. So this is the reinforcement cage, and usually we use high workable concrete, and we can control this with water, but nowadays we have chemicals, and that chemical is super plasticizer. This gives you that high workability level for concrete. Basically, we do that because we want to ensure the concrete is compacted, self-compacted kind of, and gaps are kind of avoided. So gaps between the soil, like gaps within this part, we need to make sure it's going to be filled with concrete. If I put the concrete as yellow, we need to make sure the concrete will be placed all around the steel reinforcement and around to the pile. Okay. Yes, so that's again another fact which I was telling you. Pressure of the pump and volume of discharge can be measured against auger withdrawal rate, which I showed you that monitor records, which you need to know about and confirm during a construction project. Yeah, that was the last point, was about the concrete, which we already covered in regards to the use of super plasticizer to have high workable concrete. Yeah, some pictures which will bring the situation clear. So I think what's happening here, that's the end of the toe or the end. They just typically clean the hole to make sure. Maybe I can show you some more pictures I had before, which if people still haven't really get the chance to see, I'm just going to bring something up. Cast test. Maybe I've got some. Yeah, here we go. This is just some pictures I've just found from the net for a type of. You see this one here. This is just the tip of the auger, continuous fly auger, and this one is how the hole can be. So that's the hole. Usually it can be on the side, and that picture that I was showing you, just showing you how these need to be cleaned to make sure when the design depth is reached, they start pouring the concrete from here. And there are some sensors that will typically measure the concrete pressure to make sure it's within acceptable levels, to make sure the concrete is poured evenly in the hole. What else we can talk about here? This is just start of the pouring process. Yeah, looks like it's a bit wet already. And that's just, I will show you a video that may help you to see, if not now, maybe during the workshop. It needs continuous cleaning, this process. It's not very, very kind of smooth. It's a bit rough exercise to work on because it depends on the soil condition and the type of material you're facing. So it's a heavy construction process. And I've talked to you about this. This is what kind of gives you a summary about what's really happened there. It gives you basically the pile number, depends on the drawings, the diameter, the design diameter. These are kind of the key parameters you want to check, that whatever the drawings required in terms of the pile properties, it is happening on site. This one also, so basically you wanted 600 diameter, you had a little bit more, which is fine. And the oversupply, the concrete pressure is typically giving you a positive result. So there is always a pressure there. As you go down, hydrostatic pressure will be high, and obviously gonna reduce because the level of concrete reduces. Looks like it is already at the depth. See, the depth here is again. Remember, they're gonna be stopping at 7, so they may have another pile on top of it as well. So it depends on the final design, what kind of depth they want to reach. 7.1, it's what they achieved so far. Yeah, 7.5, so they may have more to go. I think overall was about 11 or so as the overall depth, but that's what they're reaching so far, 7 point something. So these kind of what the monitor really gives the concreters and the piling contractor, but you would be understanding what they are saying as well to make sure the final design is achieved, right? And the main properties you're going to be looking after is the diameter. The pressure was always on to the end tip, and what else? The depth. These are the key parameters you would observe. The depth of the pile is above what was intended in the design. Maybe it was 10 meters, but here they started from 11, which is more than required. And there is always pressure on the sensors or on the tip of your auger from the concrete, and the diameter to be within the acceptable limits. That's basically what reporting data should be observed. Reinforcement, as we said, they're going to be submerged, and one of the key things when they prepare the ligatures, as you know, in usual reinforcement exercise, you may just manually, or they may manually tie the bars together, but with such construction arrangements, they typically going to weld them. They're going to tack weld them. So the ligatures will be tack weld typically. And usually these kind of things not done on site. They're going to be done in the factory, prepared and get craned on site. So the key point here was the ligatures to be tack welded or welded, obviously because they're going to be under pressure again as they're going to be submerged into the concrete. And sometimes if they are very, very deep, they need to get vibrated a bit. So the machine that will be pushing them into the ground, they will apply some vibrations to help them get into the hole which is filled with concrete. But yeah, as the other reasons why we use super plasticizers, because remember, we are submerging the cage into the hole. That's why you would need more workable concrete with high viscosity to allow for the cage to get placed inside the concrete. Pile cap excavated and poured later. So we know that from last week, pile caps will be placed over. Just an idea about how many in a normal good day where you don't have a lot of, you definitely, if you got some rain, you should stop working. But if you don't have a wet ground because of a rainy day before or so, you can complete it up to 9 piles per day, which is again, in month, it's going to be many of them. So usually this kind of piling exercise will happen in several weeks. It's not a one-day job to get the piles installed. This picture just gives you an idea how they're preparing the ground to submerge the cage into the ground. So the key points that we, again, as I said, with this subjects, you need to understand the lines, the information. That's how you're going to be asked. For example, what are the key arrangements need to be taken in the preparation for installing the reinforcement into a prepared pile. So first, you can say the concrete needs to be mixed with super plasticizers. We said that in our notes for you. The reinforcement components in terms of stirrups and bars, they need to be welded together. So these are the considerations you would need to consider. I'm not asking you to go and search in the internet and find things very generic. As I said, few groups really, again, for the first questions, they came up with considerations beyond what we are really after. Yeah, you took some credit points for that, but we were asking about the elements that will, if we go back to the question, as I was asking about the components that made the design and construction effective. We talked about the haunch, we talked about the bridging, we talked about stiffeners. So there are very obvious elements which did that. And some people, yeah, they just go and talk about generic construction approaches, which, yes, I may agree with you about them, but we ask you for the elements. Same thing here. When you read these notes, just understand those lines, make sure they're making sense, and that's how you're going to be asked. Yeah, I would not ask you beyond the details we talked about. So that's the process. I will show you. You can find really many resources, and that will show you a video of how they are installing the cages or submerging the cages into the concrete. Obviously, it's going to happen straight away after you finished with the CFA. When the CFA dug the hole to the depth you want, poured the concrete to the pressures that satisfies your design. All good. Then the contractors are ready with the machines connected at the top. The lifting machine is connected to the top. They will actually start submerging the cage into the ground. As I said, the key preparations, you need to know that your concrete is at the correct level of slump in terms of having super plasticizers. Slump measure is about 200 millimeters. And the components, the reinforcement components, are tack welded together to make sure. You see what they do to it. So definitely, you don't need to just manually tie it because it may get displaced and things may go wrong. You know what we are saying here? We're saying you always need to keep a room for the pile cap. So there should be a room for the cap, because when you're done within few weeks, when all the piles are placed in position, you will come and start placing your pile cap, whether it was for a retention system we talked about last week or for a tower, a building we talked about. I've mentioned to you just today. All right, so that was to do with the CFA. Do you have any questions about the CFA construction method, or any questions about the driven piles or the board piles? So far, what I've covered to you, three key things. Driven piles, the piles we need to nail into the ground for precast piles. Number two, board piles, and we said sometimes you can dig the hole, put the cage, pour the concrete. Sometimes the soil is not stable. What you do, you're going to dig the hole, pour the concrete as per the CFA method, then submerge the reinforcement. And we do have some features and details you just need to be aware about, which are clearly stated in the notes. Do you have any questions about what I covered so far before I start? We're still here talking about piling, and it's applicable for either driven piles, whether by using the conventional method or by using the CFA method. But the situation we're going to have here, it's you have water table, for example, which can compromise your concrete. Your concrete that you're using, or compromise the stability of the hole. So any questions you want to ask? Okay, it looks all clear so far. Piling under bentonite. Bentonite is again just a product available that you will think about placing in the hole, right? As you dig, because as you dig, you're going to be hitting a water table. So this dashed line just let you kind of mentioning there's a water table. And before you start digging in the water table, you will actually be placing bentonite. We'll talk about that product here. Now, one thing you need to know is not as easy as just placing a bentonite. You need to use what we call a surge tank. The surge tank will help you to make sure that the bentonite is always pushing down into the hole. If you don't have a surge tank, then maybe the water will not be statically kept out of the hole. You need a pressure, you need a hydrostatic pressure to let the bentonite be forced into the hole, in other words. So that's why we use surge tank. So there's kind of a technique needs to be looked after while you think about using the bentonite as a temporary shoring for the hole you dig. So drilling fluids, yeah. Example, bentonite. That's what we talked about. We mentioned this before. We said some situations, whether by using the CFA method or the conventional methods, we're going to maybe using fluids to keep soils, fill materials away. So as I said, basically you may have very saturated soil condition that will keep collapsing into your 900 diameter hole. So things won't work. You will keep digging the same thing every day. And to really stop that, you can use the drilling fluids. They call them drilling fluids, and one of the main types used bentonite. Bentonite is very fine clay material, crushed to ground matter. So that's really the source of it, or from where it's coming. It's very fine clay material, crushed, grounded to a powder, and it's mixed with water to form a kind of a gel, heavier than the water. That's how it's kind of chemically treated in order to form a gel which is heavier than the water, which will end up providing a coat or a seal. It will seal the sides of the hole and prevent ingress of water or sandy silt into the excavated hole. So that's basically the idea. We are trying to make a hole, and we are in it. This is your 900 diameter hole. we have a situation here where we may have a saturated sand or even water that will keep dropping into the hole that you do. So, you know, whenever you drill, you're going to have water or saturated sand coming into the hole. So what we do, we're going to be pouring that gel, which will kind of be always there, and it will seal the sides of your hole and stop that water ingress into the hole, which is the aim. So there is a construction sequence which I suggest you to really go through and imagine, and it will really help you to understand the concept of using bentonite in that piling approach. So first of all, as we said, given usually we're going to use the steel cases, which are these elements. Mostly it's required given the situation we're talking about. We're talking about a sandy soil or saturated sand. So usually the top layer of the soil will require these kind of temporary propping techniques, and that's what we're talking about. Usually the first layer, 1 meter or 1.5, will require some sort of propping, and they will be installed first. That's the first step we have there. So first we're going to be using those steel inserts in oversized hole if sides of the board holes are not self-supporting, but usually it would be the case if we're talking about sand, and that sand got some water table, so they will be typically very loose ends, and usually, as I said, for the first meter at the top we use those kind of inserts. Number 2, they start excavating for the hole to the design diameter, whether it's 600, 900, and they're going to go through the gravel sand layer where water sand infiltration occurs. So what we're talking about here, you will go with the normal excavation process, the conventional one, right? You're not pouring any concrete here. You're just going with an uga, right, without pouring the concrete, and you're going to excavate it through whatever material you find there, up to the level where the soil is again holding to itself, and until you reach the water table. So what we're going to do next, we will continue drilling to the required depth under bentonite. So at this level, before you start digging into the water table, you will start placing the bentonite product, that gel material. You will start placing it, as it says here, it's going to be under. That's number 3. So that's what they say, maintain head of the bentonite above ground level. So you can follow these numbers in line with the numbers shown on the graph. Okay. So number 1, prop the top side of the soil as required. Then start excavating through stable soil conditions, right? And up to the water level. Then you will start using bentonite. If in case you've got the like non-stable material, you still can use bentonite. It's not like you don't need to wait until you get to the water table. Sometimes you may face some loose sand at this level, so your bentonite is there, so you can also use it. Because remember, we're not pouring the concrete until we reach to the design depth. Okay, so in case you have very loose material, you can make a decision and start pressuring down your bentonite. So that was number 3. Number 4, they will dig. So under the pressure of the bentonite, they can go ahead and dig all the way to the design depth. Once it's reached, number 4 here is talking about scrub the base with the flat blade bucket. So it's a cleaning process, because usually these kind of processes will, or the liquid itself will be contained a lot of aggregates or a lot of deposits from the ground. So usually there is a vacuum kind of process to make sure and maintain only the bentonite within the hole. All right, so this is kind of a cleaning process. And while this is done, so you don't think that you're just going to use kind of a vacuum and clean, and there is a testing process which we will cover after we finish those steps. There is kind of a testing. You will be testing the bentonite. That testing process will make sure that this liquid is almost purely bentonite, and you have only bentonite within. There is not excessive water into it, because if there's excessive water, it's going to be a problem. If there's excessive water and you pour the concrete, then the water going to get mixed with the concrete, and then you may have sponge, not concrete, at the end of the day. So before we start pouring the concrete, step number 5, we have to ensure that whatever is left here is almost purely bentonite. How to check that? Yes, we do cleaning with using a vacuum system, but to check that as well, we conduct tests. Remember this, we're going to be taking some samples from the bentonite, and it's going to be tested to make sure its viscosity within acceptable limit, its slump within acceptable limit, and its chemical within acceptable limit. So these tests, I will brief you about them later on. So when you kind of ready to say that the bentonite was the material existing in the hole, then next step will be about placing the cage. We're going to be placing the cage of the steel, submerging the steel into the, so insert the cage, and insert, so they're going to put first the cage, then they're going to put the tube, the trimmer, which is going to be then pouring the concrete. Then they're going to replace with a clean bentonite if required. Then they start the concrete pour. They given keep the trimmer, which is the end of the pump. This one. Keep it 1 point, which, as we said, to make sure there is a pressure always. Like it's similar to the note I mentioned to you. So remember here we don't have an auger. It's not an auger to pump the concrete. The auger is done. The job with it is finished. Once you reached this design depth, you're going to pull the auger out, and then you're going to be working with trimmer, because it's going to be like a tube to pour the concrete, which is obviously a hole full with bentonite only. So this advice, again, it's all about making sure there is always positive pressure, positive concrete pressure as you pour the concrete, and to make sure you won't end up with gaps within your concrete. As the concrete levels goes up, they will pull up the trimmer or the tube. And while this is, so when the bentonite is going out, while you pour concrete, the concrete viscosity going to be pushing the bentonite out. So usually the concrete viscosity is lower than the bentonite, and the bentonite will be physically pushed out of the hole and then collected by the tank again, right? Collected by the tank, and can be reused, cleaned up and reused in a different project or a different pile. Remember, this is happening for each pile, this process. Okay, so please use bentonite in holding tank for filtering and cleaning for reuse, right? Yeah, then basically you will be pouring your pile up to the bottom of the pile cap, as we discuss always, and take away your inserts or the casings. So the casings, those steel tubes, if required, if this soil here was not really stable, right? So in summary, really what's happening here is you need to distinguish between the conventional case, where you've got very cohesive clay or soil, can hold to itself. We're just going to dig the piles to the required diameter and depths for 4 meters or so. This is, as I said, very usual exercise. Or it can go to 20, whatever meters, if the soil condition, if you had a very cohesive rock, floating rocks situations. If not, you may end up with the CFA method. CFA may still not work if you've got the water table issue and saturated sand issue. Then you have to use the they call it drilling fluid. Bentonite is one of those drilling fluids, and the process of how it's placed, when, what do we need to clean, which one gonna come first, is shown with those simple 6 steps. So make sure you know them. You may be asked to demonstrate them in part or in full. So sometimes we may ask you about one of the steps, what we're gonna do next, right? Sometimes we may ask you to show them in full, where you need to go through the 6 steps and yeah, get them summarized. So it is, yeah, one of the well used arrangements, especially if we have water table. As I said, usually South Melbourne or the CBD as well got many areas with water table issues. The builder then, they either need to wait until the wet season goes away. That's what sometimes can happen, but sometimes they can't wait, or just that's how it's happening. Or yeah, nobody can control the situation. If you've got water table, then definitely you need to think about using the drilling fluid like bentonite in the process to do that. In a project, don't think that all the piles will need that. Maybe you will have 10 piles requiring the bentonite shoring, and maybe the other 20 can be done without it. So really, it can vary in a project. It's not always the situation. So these pictures can quickly show you. This is the casings, that steel at the top. This one looks really decent, which is about 2+ meters in height. And again, it was there just to, you can see how the wet conditions are there. So definitely you need some propping components there, where you would think about using that casings, which was step number 1. This is the surge tank. That's how it looks like, which will always, so for example, yeah, tell me, what was the purpose of using a surge tank? So you need to talk to us about it, give some sketches, etc., which was carefully documented to you in those steps. Yeah, step number 3 is talking about it. And yeah, it's gonna maintain the bentonite pressure to make sure it will keep the water table out of the hole, and also keep any saturated sand material out of the hole. Right. That's the tanks. Definitely got a cleaning facility and filtering facility. As we said, at some stage, the bentonite, when you start pouring the concrete, almost at the end of the process, the bentonite will be pushed out from the hole, and usually that bentonite will be collected in the holding tank, where you will need to filter that and clean it again for reuse. So that's the holding tank for the bentonite. This one, it shows you, as we said, that's after drying the bentonite, the used bentonite or the new bentonite. As we said, it's a fine product for the clay. Kind of a clay product, which will be mixed with concrete, with water. It is the bentonite, in the end of the way, is a pure clay material that will be mixed with water and create that gel product to do whatever, to do that propping technique it needs to do. This is the trimmer. That's the end which they use in the hole to help in cleaning the end of the pile at the very bottom, to scrape it and also to clean it, and to make sure you have achieved a flat end, especially if we're talking about 900 diameter piles. We need to make sure, because the bearing will, as we said, the pile, in the end of the day, when the engineers design their loads for a 900 diameter, this bearing need to be really flat. So the trimmer will help in doing that as well, because this one give us a good hundreds of kilonewton to resist whatever load it's taking, beside, as we said, the friction resistance. So they need to make sure here we've got very kind of flattened surface. And that can be achieved with using these kind of ends for the cleaning, and also they will be used to pump the concrete when it's ready. That's just the cage, which you would imagine. And where we are here, just another pictures taking for a project. Yeah, these projects is not easy to hunt for when really they're doing it around, but again, they usually done. You don't know, like you don't see them from a public side. Usually they are inside in construction. I trust at this stage you know all the details behind it, and you have some sort of educational experience about using them. All right, now it's 9:56, and what's really left, it's very, I will take you through these kind of notes during the workshop, maybe about 30 minutes during the workshop. Basically, it's the tests. So as I said to you, after you collect the used bentonite, we have to test it. And there is a number of tests we do. There is very nice clip videos which shows you a real engineers how they do the test for the bentonite to make sure its sand content, for example, is acceptable. So in order to keep using that bentonite, and also to make sure that the bentonite was the only product staying in the hole. Remember here what's happening between these two steps. Between step 4 and 5, we need to make sure before we pour the concrete, we need to make sure the bentonite is purely there in the hole, not heavily mixed with sand, not heavily mixed with water, because if it was not in the right level, then you pour the concrete, then the concrete won't be concrete anymore. It may be, you can't just add more extra water to the concrete. It's going to be very very soft concrete. So remember, we are after 32 MPa pile. Remember last week I showed you drawings? The engineer wanted 32 MPa or 40 MPa. So you have to make sure the concrete mix is going to stay as it is. So what we're saying here, we have to test the bentonite before pouring the concrete, and also when after we collect the bentonite. So we check the pH level, right? We check the sand content, we check the density, we check the viscosity to make sure it's going to do the job it's supposed to be doing. What else? Yes, these are the main checks. I will take you through. They very straightforward to take you through, but you may be asked about, so you need to know them to see how the whole story works together. Now, after we finish the tests about bentonite, I will take you through a case study. And this case study will talk about using the very last type of piles we want to mention to you, which is the sheeting piles. Okay, I think one of you have mentioned. We'll talk about this situation, which is again used for specific needs. We will cover them Wednesday. And so the plan may be about 30 minutes. We'll again talk about the notes, just to confirm your knowledge about piling systems. And yeah, this week will be the end of piling system. Next week, we're going to talk about a different component to work with. And then maybe 1 hour and a half. Please prepare any questions you have for your second assignment, or any questions you have for the subject. We may have more than 1 hour to solve some of the other questions I have for you to do. Not solve, just to give you some hints. All right, that's it for today. Any questions before we stop the meeting? We stop the record.